And inside here, I've uploaded the instruction detail as well as rubrics for you to get to know what do you expect in terms of assessment and evaluation of your submission for assignment 1. And the due date for submission of assignment 1 is I will give you about 1 week time. I think this one is not like very tough task for you guys to do, because we have 3 questions and you have 3 group members inside your group. So one student maybe pick 1 question, and also you need to come up with a report at the end of when you try to compile all the answers. Okay, 2 updates. First is about tutorial. Please download this file now, because we're gonna discuss about this the question inside the tutorial. And also this is information for you guys about assignment number 1. All right, that's for the first one. The second one is about our tutorial. If you download the file available in e-learning, this is the file actually. You need to download it, and if you look at the question I've given in this tutorial, we have 3 questions. I believe the question that asked in this tutorial is based on I pick up from 1 or 2 sample of our test 2 questions. So if you look at question number 1, asks about sketching a phasor diagram, where you try to illustrate the phase shift between 2 sinusoid. This is the first one. We have I1 and also I2. And if you look at the sinusoid given in the question, the first one is in terms of sine, the sinusoid equation, and also the second sinusoid equation, i.e. I2, is in terms of cos. So you need to somehow make those 2 sinusoid in similar or in identical terms. If you prefer sine, means that this I2 should be converted into a sine equation. If you prefer cos, means that this I1 should be converted into a cosine equation. And please remember that although you convert into a cosine equation, I2, here we have a negative sign, means that this negative sign should be eliminated. In other words, you need to do something in order to eliminate this negative sign. Both should be in a positive value, positive equation. That's for question number 1. And for question number 2, if you look at question number 2, a simple circuit given in question number 2, we have a series parallel circuit. We have about 1, 2, 3, 4, 5 components connected in series as well as in parallel. So here the main idea is to find informations in this circuit. In other words, we try to analyze this circuit in terms of information of current, maybe voltages, or maybe impedance. So in question number 1, The first one, we try to calculate the total impedance, and from this value, we try to come up with the supply voltage equation. If you look at the second section, V of T means that you need to come out with the answer in terms of the sinusoid equation. And later on, calculate Ix, I current flowing through this resistor in phasor form, and also voltage drop across this inductor, 150 millihenry inductor, also in a phasor form. That's for question number 2. And for question number 3, we try to analyze a circuit using a node analysis. Here, you need to solve current Ix using node analysis. And if you look at the circuit, we have one voltage source. How do you know this is voltage source? Because we have 20 angle 0 degrees V books, means that this is considered as a voltage source. And we have about 5 elements or 5 passive components connected in series and also parallel. You need to find Ix using node analysis. Okay, now it's 11:12, and I would like you guys to have a look at these 3 questions first, at least answer at least one, and then later on at 11:30 we try to discuss the answers for question given in this tutorial. I would really appreciate if you guys, one of your colleague could present or could share his or her answer over here, and later on I will give you the full answer. If no takers, I mean no one would like to share, means that I also will not share my answer. Okay, give you guys about 15 minutes. Maybe the easiest one, maybe question number 1 to answer that one. So I need you guys to answer question number 1 first, and later on we'll discuss about the solution. Okay, leave you guys. We meet again on at 11:30 a.m. All right. Any questions so far?
No.
Okay. Please proceed, and we meet again at 11:30. Okay. Now it's already 11:30. Have you finished question number 1?
Yes, sir.
Okay. Could someone tell me what's the answer for phase angle?
210 degrees.
210. Wait, I'll check my answer. No. The answer is 150 degrees. Okay, which one is leading?
I1.
I1 lead I2 by 200 something, right? That's your answer.
Yeah, that's my answer. The wrong answer.
It's okay, it's okay. It's supposed that I1 lead I2 by 150 degrees. The angle of I1, okay, later on I'll share you my answer. Uh, did anybody try to answer question number 2, at least the first section, the first one? Anybody? No? No. Okay. Right. Now, I will share my answer now. Hopefully, this would help you to get the idea of how to solve this one. All right. If you look at question number 1, this question number 1, as I mentioned earlier, it's a very famous question in terms of determining the phase angle and also describing which one leading or lagging with respect to each other. All right. Looking at the first question, here is the solution and how I got my answer. If you look at the question, we've been given with two sinusoid, I1 and I2, where I1 is given as 5 sine omega t plus 30 degrees, and I2 was given as negative 10 cos omega t minus 30 degrees. All right, the strategy here is that we try to write down both sinusoid equation in similar pattern or in similar form. The top answer that you seen here is that we try to convert this I2 um, in terms of sine. So then both sinusoid I1 and I2 later on will be in the same form. The first one, I1 is 5 sine omega t plus 30, and the second one, I2, also we convert I2 in terms of sine as well. So conversion from cosine to sine, you need to be particular with uh, the negative sign at the front of the equation, and also the the form of trigonometry equation available for I2. So I2 here, first we have negative cos omega t minus 30, and we first convert into this, we first eliminate this negative sign by adding 180 degrees. So by adding this 180 degrees, we will eliminate the negative sign at the front of the equation. We have 10 cos omega t plus 150. And since we need to make I2 in the same form as I1, we try to convert cosine into sine, where we will add 90 plus 90 degrees in our equation. So here, the final form of I2 with respect to sine is 10 sine omega t plus 240. And it's very good idea if you convert this time domain equation into a frequency or phasor domain equation as available in your right hand side of the solution. Here for I1, it will be given as 5 with the angle of 30 degrees. It's very simple. We are taking the magnitude of the sinusoid and also the angle of the sinusoid. And since both are in the same form, sine and sine, for I2, if you try to convert into phasor form or frequency domain, it will be given as 10 with the angle as 240. As I mentioned earlier, we try to make these two in the same form because we would like to determine the phase angle or the phase difference between those two sinusoid. And the way we calculate the difference is by drawing the current vector or the vector of I1 and I2. Please remember, I1 and I2 should be in the same sinusoid form, where if you have sine means that both should be in sine as well. So now, if you try to draw it, it's very easy. For I1, it's given by the vector over here. Maybe I try to annotate a bit. So I1 is here. And remember that the angle should be a 30 degrees angle because we have a vector 5 with the angle of 30. And for I2, we have 10 with the angle of 20, so 240. So here is the vector of I2. So based on these two drawings, you can see that the phase difference is given by this angle. Okay, this angle is the phase difference of I2 and I1, and that's why we got our answer as 150 degrees here. And since I1 is up here, so we can say that I1 is leading I2 by 150 degrees. Actually, if you try to convert or try to represent your current waveform in terms of cosine also can, where here I have another solution, but both giving me the same answer. However, the graphical representation is a bit different compared to the one that we seen earlier. So now in my second solution over here, I try to convert, I try to represent both equations in terms of cosine. And if I have a negative cosine, a negative sign at the front of my equation, I need to, sorry for that, I need to change it into a positive sign. So for I1, since we have sine, we need to convert into cosine, where to convert into a cosine equation, I need to minus 90 degrees for the angle. So here, my I1 can be written as 5 cos omega t minus 60 degrees. and in phasor form is given by this 5 with the angle of negative 60. And for I2, we have a negative sign at the front of the equation. So I need to remove this one. To remove the negative sign, I need to add 180 degrees. And since I need to compare both in cosine equation, so that's it. I don't have to make another modification on my I2 equation. So I2 can be written as 10 cos omega t plus 150 degrees. Also, you need to convert into a phasor domain or a frequency domain where the magnitude and the angle is given by 10 with the angle of 150 degrees ampere respectively. So to compare both equations or both sinusoid, I need to use graphical representation. So here I will draw my I1. I1 here with the angle of negative 60, and my I2 with the angle of 150 degrees over here. Sorry, 150 degrees over here. Here is the phase difference between both sinusoid I1 and I2. So a bit confusing because both value is the same. However, to draw I2, I will use this angle. Oh, sorry. I will use the angle over here to draw my I2 because I2 positive 150, and here is the phase difference. Phase difference is over here, and look over here, here is about 30 degrees, and over here is about, from here to here, it's about 120 degrees. So adding that two angles, we will get 150 degrees as our phase difference between I1 and I2. And looking at the how do we determine whether one leading or lagging? So here we can say that I1 is leading I2 by the angle difference we calculate over here. So this is how we answer question number 1. So any question so far?
Sir, can we write that I2 lead I1 by 210 degrees? Is that correct?
Wrong. You cannot write that one. Because yeah, it's a bit confusing, right? Which one should we take as as the phase difference? Because the phase difference over here should be 150 degrees. That is based on the difference you seen from this. Sorry, I would like to draw it here from this vector and this vector. Although you see here, over here is 240. However, the way we try to determine which is the phase angle, you should get into the counterclockwise direction from the first vector into the second vector. If you look here, the second vector, the first vector over here is, if you look from counterclockwise direction, here is also 150, and here is also 150 degrees. Clockwise direction. I'm sorry for that, not counterclockwise.
Okay, sir, understood.
Okay. Sorry for that. It's clockwise direction, yeah, not counterclockwise.
Okay.
All right. Any question? Can we proceed with question number 2? The one that who asked the question just now?
Me, sir.
Who? Your name?
Nasif, sir.
Nasif. The one that Nasif asked is very important question for you to take note, because I also expecting that you are asking about that kind of question, because it's very confusing. Which one should be the correct way to determine the phase difference between those two vectors? All right, please take note of that, yeah? Clockwise direction. Okay, for the second question, right? The second question also is a very popular question in your test. Looking at the question here, we've been given with a circuit and voltage is not given. However, the current is given as information inside the circuit. And we have about 5 elements, and all elements is given in terms of its particular units. For example, for inductor is given in Henry, and for capacitor is given in Farad. We have a question. The question asks about, the first one is Z total, or total impedance. To get total impedance is the impedance looking from the source we are considering. So now, before you start your calculation, please make sure you do this one first. I mean, you write this information, because this is easy 1 mark for you. You are converting this current information in sinusoid into a phasor domain. And maybe this should be enough, or if you would like to convert it into rectangular, you can do that as well, because this is for your own convenience later on. Okay, the most important thing looking at the to answer the question is to convert all information of components in the same units. In other words, you need to convert your inductor and also your capacitor in reactance form, because reactance units is ohm, and for resistor it's just the real part of your impedance. So now I've simplified my circuit, where the first one is the combination of resistor and inductor, noted as Z1. This branch, resistor branch, noted as at Z2. The last branch over here is noted as Z3. And please remember that if you have this inductor, you will actually calculating the value of XL, where XL is given by J omega L, or J 2 pi F times L. So now you don't need to calculate the value of your frequency, because in the question omega is given as 377. So just use that value as adopt that value as your omega, and you can calculate XL using this equation. And as I mentioned earlier, Z1 is combination of R plus JXL. Okay, in your solution, you should clearly state whatever you calculate. Okay, here not just giving me the values or the numbers. You also need to state, okay, this Z1 is R plus JXL, for example. And after you calculate, you will get your Z1 as this value, and you can always use or you can always convert it into polar form for your convenience later on in your calculation. And also for Z3, Z3 is combination of XC and also XL. Maybe I will label this as XL number 2. This XL1. Oops. It's okay lah. XL, this is X2. And basically for Z3, what you will have here is that combination of these two is given by negative JXC plus JXL. And to calculate XC, here is the equation. XC is given by 1 over omega C. So C is 5 micro, omega is 377. And later on, you will end up with this answer. So maybe I erase this one first. This is the combination of this part and also this XL part. So you will have Z3 as negative J473.95. And also you can convert into polar form or phasor form. It's given by this value. And maybe I forgot to write the units over here. That is for Z3. And Z2, we come back to Z2. Z2 is basically just a resistor. And Z2, if you would like to write it, is given by R plus JX. And since we don't have this value, so Z2 is only given by R. And R 5 in rectangular form. If you try to find what is the phasor form or polar form of Z2, is given by this value 5 with the angle of 0. And later on, you see that these two are in parallel. So solve the parallel connected elements, and you will come across this. I note this one as Z4, where Z4 is given by Z2 in parallel with Z3. And the way we calculate is like this: Z2 times Z3 divided by Z2 plus Z3 for the parallel connected impedance. So at the end, we will get our answer as this one, 5 with the angle of negative 0.6. Or you can always convert into rectangular form as 5 minus J 0.05 ohm. And lastly, we try to calculate our total total impedance. It's given by combination of these two elements, Z1 plus Z4, and you just add that one together and get your answer as this value. If you have, if your answer is slightly different from what you've seen over here, I think it's okay, because maybe it's due to the decimal points and also the conversion between polar to rectangular when you try to convert your values. it's okay, but the value should not be varies as far as not to differ lah. I mean, not too far. It cannot be varies too far. For example, if you have here is about 15.01, for example, and then your answer will be acceptable, or your answer is 14.8 something, 82 degrees. Then your answer should be acceptable. And here, let's say you have J1.845 for 1.8 1.793, for example, then your answer should be acceptable. I understood that the variation of the answer is due to the conversion of polar to rectangular, as well as the decimal point that you are considering in your calculation. All right, that's for the total impedance. And for the voltage, we will use Ohm's law, where Ohm's law says that V equals to IZ for AC circuit. So we have the total current. Basically, I here is I total, and we will try to multiply it with our value over here, Z total, to get our voltage from the source, voltage over here or over here, right? We know what is the current, and also we know what is the impedance, total impedance over here, and we just apply Ohm's law to get our answer of the value of voltage supply. And since you see that in the question earlier, if you look at the question, supplied voltage V of t means that you need to write your answer in sinusoid form. So here I also, here I also convert my answer. First one, I will get my answer in polar form and try to convert it into a sinusoid form. And conversion from this one to this one, I think we're just taking the magnitude, put it over here, and the form or the sinusoid is in terms of sine waveform. The omega is kept the same as earlier we see it for current, and the angle that we found here, we will put it as the phase angle of our voltage. And if you leave your answer up until this part, what would happen? You will miss about half marks because you didn't put your answer in sinusoid form or time domain form. Only 5 marks, but this one is very important. For example, if this is 1 mark, maybe you will have half mark over here because you try to calculate using Ohm's law, and half mark you will be missing because you didn't change it into a time domain representation. All right. Later on, we try to calculate current, and I think, maybe you have other solution. I think the easiest way or the fastest way to calculate Ix in the question is by using current divider rule, using CDR. So to calculate Ix using CDR, I will use this equation where I know the total current coming before it divided into these two branches. So the total current is over here, or the current that coming before the current division. And to calculate Ix, we will use this equation, where this equation, the way we write it is that Z3 divided by the summation of these two impedance times the current coming through before it been divided into 2. So please remember that this equation only works if you have two separate branches, two branches. If you have like 3 branches, for example over here, you cannot, for example, this is Z, let's say this is ZX. You cannot just simply put plus ZX over here. That is wrong. Okay, that is wrong. You need to use other um, equation, or you need to use other alternative other methods in order to calculate IX. Maybe you will you need to revise back the material that I showed in DC circuit analysis. All right. Remember that this equation only works if you have two branches. If you have 3 branches, you cannot use this formula. And the difficult part, I believe, in order for you to calculate this, the difficult part is that you need to deal with a complex number, where complex number, it involves magnitude and also the angle. They, if you have like division over here, the first one, yeah, it's okay if represented in a phasor form, but the one that you have down here is in rectangular form. So to calculate it manually, you need to convert it into a phasor form or polar form in order for you to easily divide these two quantities. And for calculators, advanced calculators, maybe you can just simply you don't need to convert this one this rectangular into a polar form. Just put it in your calculator and simply give you the answer. But if you try to calculate it manually, means these two cannot be solved unless you convert into a similar form or in polar form for division. Same goes to for multiplication. If you try to multiply a complex number, make sure it should be represented in polar form. And here's the answer for IX. And for the fourth question, or fourth one section is to calculate what is the here, what is the voltage across this element? The voltage across over here. The voltage across over here, I think the simplest way to calculate the voltage is by knowing what is the current flowing through here and multiply it with the value of XL2 using Ohm's law. So that's what I do, what I did in my solution, where in order to get what is the current flowing through here, remember that Z3 is the combination of XL and XC, but we are only trying to calculate what is the value of current first. So IY is given by the total current minus the current over here. You will get the current flowing through here, the value of current here. And here's the answer for IY. And I will use IY and multiply with the value of my XL over here. So here is IY times JXL. So, maybe here is this one. Okay. Maybe not good lah. Okay. IY times JXL. So this is JXL that I mentioned just now. 377 is my omega. 150 milli is my inductor value. And at the end, I will get my Vx as this answer, 2.226, 2.262 with the angle of 146.31 degrees volt. So the strategy, I recall back the strategy. Okay, the strategy here is that I already know my current over here as Ix, and the way I calculate the voltage across this part is by calculating what is the current flowing through here and multiply with the value of XL value and the reactance value, and I will get my Vx as in the solution here. Okay, right, any question for question number 2? Any question?
All good, sir.
Okay, I will proceed to the next question. Next question is about nodal analysis, where we try to solve this one using node analysis. So here, to solve it, to solve Ix using node analysis, first you look at the question first lah, and you'll see that we have 5 elements, all written in its reactance and also in its resistance value. So you don't need to calculate what is the value of reactance. Of, for example, this is the capacitor. You don't need to calculate the value of Xc because it's already given in Xc, and also in the value of reactors here for inductor. You don't need to calculate it because it's given in XL value. You can just proceed with your node analysis, where here is the solution. And remember that for node analysis, the first one we need to do is to assign the current direction. If you look at the question, okay, here is the question. Right. Okay, current direction were not assigned in the question. So you can simply you can first assign the current direction and keep the current direction towards your whole calculation, in your whole calculation. So now I considering, or I assuming that current at these 2 nodes is the first one I label as I1 is flowing from V1 node into my ground, and I2 also flowing out from node V2, and I3 also flowing from V1 to V2. And at V2, I have Ix. Ix already been assigned, so I leave it like that. And for I4, I assign it as current flowing out from V2. So if you like to do, or if you like to assign the current in different direction, also you can assign that one. But please remember that you must keep the direction throughout your calculation, throughout your analysis. So your analysis will be correct throughout towards the end. All right. Now I've assigned the current direction, and now I try to assess the KCL, current coming in, current flowing out, from the node. So I assess first the node V1 first. For node V1, here, if you look at the current direction, I1, I2, and I3 is the current flowing out. So I out should be equals to sum of I in. Since we don't have the current flowing into V1, so that's why here I in is 0 and I out is given by these three currents. Okay. The way, I mean, the difficult part in nodal analysis is the way we try to process our equation. So equation, if you look at the second line over here, we have denominator represented in imaginary value. So in other words, we have to deal with complex number in our denominator part. So the first strategy that I will use is that I'll try to eliminate all these denominator terms by multiplying the whole left and right in the equation with J2 times 2 and also minus J2. If you look at if I multiply both sides with these terms, you see that the first one here, V1, at the end, I will have to multiply with 2 minus J2. And for this V1 minus 20 degrees with angle 20 degrees, I have to multiply it with J2 times negative J2. And same goes to the third term, V1 minus V2. I would have to multiply it with 2 times J2. So here, you see here, the denominator part is eliminated and you will live with an equation consists of numerator part. Numerator means the one at the top. All right. Now I simplify my equation, and at the end I will end up with my first equation over here. Equation number 1 given by 4V1 minus JV2 equals to 80 with the angle of 0 degrees. Okay, you need to revise back how to do this. Yeah, you need to go through later on. For node V2, okay, node V2, again we are applying this kind of equation or KCL equation. So I naught or I out is equal to sum of I out equal to sum of I in. If you look at this node, the current coming in is I3 and current coming flowing out is IX and I4. And that's why here we have I3 equals to I4 times, I4 plus IX. And the second line over here, the same strategy that I use up here. So I have I3 is given by, for example here, V1 minus V2 divided by negative J2, and for I4 is V2 divided by J2, IX is V2 divided by 2. So here you see that I just putting back or I just writing back the current equation in terms of voltages. And when I try to write my current in terms of voltage, I will come across with a complex number where in my denominator part I have imaginary terms as well as the real term. This is considered as complex number. And my strategy is to eliminate this denominator part. So the way I eliminate this denominator terms is by multiplying both sides with the one here. I need to multiply with negative j2 negative j2 times j2 times 2. And if you look at the next line, for v1 minus v2, I need to multiply with j2 and 2. For the second term, where v2 over here, v2 needs to be multiplied with negative j2 and 2. And for the third term here, we also have v2. v2 need to, the third term we need to multiply with negative j2 and j2. And expand the equation, and you will have a simplified version of the equation written as in equation number 2. Then, since I have two unknown variables in both equations, so I need to determine the V1 and V2 by using simultaneous equation. And you can use simultaneous equation, or in my solution over here, I will try to use inverse metric, because inverse metric is very simple for me because I'm using MATLAB. So MATLAB can easily calculate the inverse matrix of a complex number, very easy. And you can also use a substitution method if you like, or you can use elimination, but I believe elimination is a bit difficult. Substitution lah, yeah, the best way if you don't want to use matrix. But if you know how to write it in matrix form, you can use inverse matrix in order to calculate your V1 and V2. But from here to here, there's some missing part over here where what I did was I tried to, let's say this is matrix A, okay, A, this is my X, B. Okay, this is matrix A, this is matrix X, matrix B. So if I like to find matrix, what is matrix X? What I should do is I take the inverse matrix of matrix A and times with matrix B, and I will get my answer as this one. Okay. So here, it is given that V1 value is 10 volts, and for V2 here is J10 volts. So looking at the equation back, the question back, if I like to find what is the value of Ix will be given by V2, because this is the voltage over here, divided by resistor of 2, or divided by this impedance. So Ix is equals to V2 divided by 2. So here I have my Ix as J5, or can be written in polar form as 5 with angle of 90 degrees ampere. Okay, that's the solution. Do you have any question so far? Or you have any question for question number 3 solution?
It's a bit complicated, sir, but it's all good.
It's a bit complicated. Yeah, because we are dealing with a complex number. Of course, it's complicated, and sometimes I also make mistake. So that's why you need to familiar yourself with calculation involving complex number. And believe me, if you don't do exercise, if you just see the solution and do nothing about how do we get this value, this value, this value? And believe me, towards the end or during the exam, you will find it very difficult in order for you to get at least this equation. So my advice is that you should redo this solution and find your way, find your own understanding on how to deal with complex number. The the analysis or the strategy of nodal analysis is, I think, the same as what you've seen in DC circuit. However, in AC circuit, it's a bit complicated because it involves complex numbers. So practice yourself. If you practice, I believe it's gonna be okay. And of course, to solve two unknown variable, you have a few options. Here, I use matrix form, or I try to write down my equation in matrix form, and later on, I try to um, make use of the inverse matrix in order for me to get my answer. So you can also use this kind of strategy, or you can always use your own preference. For example, maybe substitution. It's is a bit, what do you call it, easier or simpler for you, because now here I'm using a software to inverse the matrix and to do the multiplication of complex number. And you can find your own way or find your own preference in order to get the answer. Okay, any question? Any question? Do you want the solution?
Yes, sir, of course.
Okay, I will upload the solution right away after this class, and please do some practice or to do back the for example, yesterday Izaidi asked me about example 10.2. Very good, Izaidi. He tried to do back the solution, and he says to me that my answer is a bit different from the one that available in the textbook, because I don't know why lah, but I did my calculation later on and find that there's no problem with the solution. And also Izaidi found that he made a mistake, a careless mistake in his solution, and that's why he didn't get the answer. So you also need to do practice. The moral of story over here is that you cannot just have a look at the solution in a glance. You need to really calculate that one, the quantities that are in the solution, because maybe you see that you think that this is quite easy, but believe me, during your assessment or during your test or final exam, you will find it's very hard because you don't have any practice before this. So moral of story is to practice lah. Practice make perfect, I believe. Okay. Now I think I spend a bit. I've spent a bit time. I mean, we're supposed to finish our class at 12:15, as I promised earlier, but now it's 12:24, 25. So I spent about 10 minutes extra. Sorry for that. But I think this is quite important for you guys to to know how to solve this kind of question. All right. If you don't have any question, maybe I think we will end our session, and please do your exercise, and also please discuss with your friend about assignment number 1. The group members can is available in the assignment details, assignment instruction. You can see that in page 3, I think page 3 or page 4, I've uh, put a table where you can get to know who is your group member. Okay, if you don't have any question, as usual, I need to um, take a snapshot of your attendance. Please turn on your webcam. Kauru, are you driving? Are you driving, Kauru? Very dangerous. Okay, anyway. See you again next week on Tuesday. We will continue our lesson. Again, in AC circuit analysis, we will have a look at superposition and also source transformation. And that one also crucial for you guys. Every content is crucial, I believe. Okay. See you guys next week. Assalamualaikum. Stay safe, everyone. Bye-bye.
Have a good day, sir.
Thank you, Doctor.
Happy holiday.
Happy holiday.
Waalaikumsalam.
GMT.